first, I just wanted to explain a little bit about the U.S. Digital Service. So the U.S. Digital Service is here to deliver better government services to the American people through technology and design. People in the U.S. Digital Service work for the federal government. We are civil servants, we're not contractors, and work for the executive branch, and do a lot of projects kind of scattered all over the government. We're going to be talking about 3 projects today. We're going to talk about there we go. No. Okay. Well, we'll be talking about, I'll talk about Vaccines.gov. Rick will talk about a simple report and, report stream. And Marc will talk about Covidtest.gov. I'm sorry. So we're going to talk about how SRE was an important part of all of these different components of pandemic response at the federal level. So this is a little timeline. That's the order we'll be talking in. First, Rick will talk about the testing and reporting data pipelines. I'll talk about helping people find vaccine appointments. And Marc will talk about the at-home COVID tests. We needed different responses as the pandemic situation evolved. But there was a digital component in all of these, and SRE was a really important part of all of these components. So I'll hand it over to Marc to talk a little bit about differences operating in government and industry.
So before we start, just a few words about the differences between operating in government and industry. If I had to summarize it, I would say that the biggest difference is that the amount of regulatory constraints and administrative complexity in government is higher than pretty much anywhere else. And this is true both in the civilian areas and the non-civilian areas. And for the 3 years before I came to digital service, I worked in a tech startup where we were in the aviation industry. And this is really still the amount of regulatory control, administrative burden is really substantial. And this is including, this area that we're talking about is public health. And in public health, you have so many different government actors. You have the federal government, you have the states, you have the territories, you have the counties, you have the cities, and all of them have overlapping sets of responsibilities around the public health mission. And so the regulations that you're familiar with, like GDPR or SOX, are complemented in the government side with FSMA and FedRAMP and the NIST 800 series of publications, and these apply much more broadly to many more services than you might see in industry. Another real difference between government and industry is the objective function. In industry, for the most part, the objective function is pretty simple. You're either trying to grow revenue or you're trying to grow profit. And that's not strictly true if you're in a nonprofit or a B Corp, but that's not the majority of industry. So what is the objective function in government? Well, I mean, it's not these, right? It's not growing profit, it's not growing revenue. And it's not always clear, and it's not always clear, and it may depend on what you're working on. There's something about governance, good governance, spending money wisely, making sure that everyone is served. But it's really not easy to create a succinct objective. At the digital service, we've sort of settled on this as our priority function. And for projects that come to us or that we go out and seek, we're trying to do the greatest good for the greatest number and the greatest need. And that's, I think, about the best you can do. The last thing I'll say about the difference between government and industry is that in industry, when you're launching something new, you often have the opportunity to target just a subsection of the customer base. Let's test this out with people who are young or with this segment. In government, we usually don't have that sort of luxury. When we launch something and it's for the public in the United States, we need to be it needs to be usable by people who are old and people who are young and people who have a lot of education and people who have little education. and people who are blind and people who are deaf. And so that is a really substantial difference that on day one we have to actually hit the entire target. And that means we have to operate in different ways. And with that, I'm going to hand over to Rick, who's going to talk about the data pipeline.
So just the first little poll of people in the audience. Who in the audience has had a COVID test? I expected that response. And when you got a COVID test, who's had a test from not their doctor or not in a hospital, so a non-traditional COVID setting? Many of you did. And so that is the problem that we were faced with as a nation when we started the pandemic. The nation was responding. COVID testing became one of the most important ways that we could fight the virus. And so the nation set up COVID testing sites everywhere. Schools, jails, nursing facilities became COVID testing sites. I have a picture here of a COVID testing site that we worked out and found in a parking lot. And this was happening all over the nation repeatedly. And so when you have a new COVID testing site and a new place, a parking lot, it does not have what's called electronic health record system. It doesn't have something, there are just people there doing COVID tests after and ever. And so what they do is they generate a lot of paper. They have paper about how this test was positive, this test was negative, and they take that paper and they ship it off to the public health department. Now at this time, and what you get in the public health department is an avalanche of paper. So what's wrong with paper? Paper is good, I mean, it's permanent and such, but as you know, paper generates manual entry. And of course, manual entry has manual transcription errors and all these problems. It takes a lot of people, a big workforce that had to be set up at the public health department with paper. But the most important problem with paper is that it's slow. There's a very large delay from that time that test that you took and got a positive or negative before it's entered into a database at the public health department. That delay is very important because particularly at this time, opening and closing, the shutdown of whole cities or economies are being determined by the positivity rate on testing. So remember that time. The positivity rate was the most determining factor for opening and closing of schools, opening and closing of businesses. And so the whole economy is depending on this one number that we're trying to get at. And it's because it's slow on paper, we were building this decision on delayed or faulty information. So our solution was nothing spectacular. We built a website to help people called Simple Report to help give an EHR to these new testing facilities that were being set up in parking lots, nursing homes, places that you wouldn't have an EHR. And then we built a companion product called Report Stream, which would deliver the results from these new testing facilities and new testing apps that are being set up and deliver them to public health departments. It delivered to multiple public health departments because, as Marc mentioned, there's jurisdictional overlap. You have a local county department, you have your state department, you have the federal government, all doing different parts of the response. So this is a picture of what SREcon23.gov looked like. It's a basic React app, a single page app. It was given to new testing facilities. Its key feature was that it could be somebody could be trained in 5 minutes, at most 15 minutes, to use it. And it wasn't just a form. It wasn't just a form, repeat, repeat, repeat. You aren't filling a form 15 times. It was actually something that was built with the nurse that's giving hundreds of tests, or the administrator giving hundreds of tests and making their workflow fast. And so it had little things like timers about if you have to wait 15 minutes before the COVID tests came up, and it had a roster so that you didn't have to re-enter everybody's name and entry. Entry was much faster than that. And it worked great. It was something that that everybody who used it had glowing things to say. This is just the right tool that I needed for doing this work. The second product we built was called ReportStream. ReportStream was trying to figure out the mess that actually is the reality of public health. What's happened in the nation is that because it's a federal government, a federalism, because authority is devolved to or placed in counties, states, and the federal government. All three places have overlapping authority, and they have all different ways they like to receive the COVID test data. They have different formats they like. They say they have the same formats, but they have different ways, like even little things like dates on that. They'd like to have dates in different formats and all that. And ReportStream is trying to do is have one way of reporting to ReportStream for senders so they can send to the nation and then give it to the states in the way that they want it on that. So it's just a big data pipeline. Okay, so you probably gathered by now, the problem here is how to do this fast. And Marc has talked about the burden of all the regulations that we have to do something in the federal government. And we started with a zero blank slate. We had nothing, and we had to go and build something very fast onto that. And so to do that, two techniques were used that really paid off. One was what's called the lean startup methodology. I'm sure everybody's familiar with that. Go for a minimum viable product. Only do the things that you need to do. Do the things that you do that learn as you do things, not as you don't study, learn, ship and learn. Those are two values that we had that really paid off well. And the second thing, I think this is kind of smart on our part, we didn't try to build one big project, we tried to build two. Like I said, ReportStream, a simple report, two different projects with two different leaders to talk about two different problems. And we separated our work and so that we could scale each independently. We didn't have to have a lot of bigger meetings, we had smaller meetings because of that. And the result was we were able to collect and deliver our first test result in 6 weeks onto that. And there's other people who've probably gone zero to delivery in less time, but for a government project, that was pretty close to a record. Here's a look at our architecture. Again, nothing very, this would be common practice. I would call it common practice. It's a microservices architecture with using serverless cloud infrastructure onto that. You might see things there. I've tried to take out the names of the products we're using, but many of the sponsors of this company, of this event, are listed in this stack that we're using here. On that. Here's where DevOps sort of came into this. We're really key to, I think, key to being these projects being successful. First of all the leaders like myself the engineering leaders were from DevOps, and that's really gets back to the system thinking that we have as a profession or as a practice. And we're just sort of natural leaders on that type of thing. We adopted, just from the beginning, naturally, SRE practices. So we logged everything, the audit trail. We knew that we were actually planning for the incident before we even started. We said, okay, there's going to be incidents here. We know we're going to have incidents. We have to have all the logging and things like that. Many startups actually leave out that part. They focus on the value proposition. They just leave that out. But we from the beginning, put that in there. Of course, we did all the standard practices that you guys are talking about, infrastructure as code, repeatable continuous integration, integrated DevOps teams, all those things were standard practices that we introduced. And that was actually new for the CDC, and we're working with the CDC. That was new. That was something that we got a lot of people looking at us and say, what are you doing here? But it was the pandemic, and we were on a deadline, so they let us go. One of the things that I thought was very key here was this idea of, we had SRE values, and the blameless retro, like Amy was talking about, that was a key value that we had. And we practiced that really hard because we did have incidents, we did have things break onto that, and we just did talk about the way, how to do this, and we sort of demonstrated that we can talk to that, we have continuous improvement with that, and we would build a sense of trust within the team about this. And that, the idea of a blameless retro is actually foreign to government. You might have noticed that it's kind of political sometimes, and it can be a lot of finger pointing going on in government, going on that, and the risk tolerance, the lack of trust in the government is actually there. So this was something that we brought to it. And so the net result is actually it worked really well. And we were able to handle, we set it up for school testing, getting things open for school testing, and then came the Omicron spike, right? That you all remember this happening. This was like a 20x, 100x event for us in terms of number of tests that came in. All this, also the whole nation was testing continuously, and the spike was there. And a serverless infrastructure just scaled, no problem there. In fact, because we had done load testing and we had been practicing things for these types of events, we were very confident that it would, and it did perform. Final results type of thing. We said we have this number is actually much bigger right now, but 33 million test results delivered. That's a lot less paper in the public health departments. And so if there was 33 million different pieces of paper sent to the health department, now we're not those papers are no longer there. They get the data faster, so we feel really good about that. We signed up over 15,000 different facilities to use our product. So that's 15,000 parking lots that are now delivering data faster to the nation, the public health department. And we are really proud about the diversity of places that we got to. Nursing facilities, long-term care facilities were our biggest customers, but we also had a lot of schools that doing that. And then we went down to there, including many jails and places of that, as well as what are called federally food shelters and places like that. So, and even more important, the stuff that we built is being used and being part of the response in the next pandemic that we're preparing for at the CDC. With that, I'd like to go back to Amy.
Hey everyone, I'm back after a little bit of a rough start personally. So who remembers early 2021, that scramble to get that first vaccine dose? Yeah. So everything I'm about to tell you happened in that environment, in that very anxious kind of rush of an environment. And I'm going to tell you about how we built Vaccines.gov, but more importantly, I'm going to tell you about how SREs focused on service delivery can act as a unifier across stakeholders. Now, first off, this is what Vaccines.gov looks like today. This is a search I actually did myself. My baby turned 6 months. I was looking for someone who could vaccinate a 6-month-old. You can see we have a map. We have some information about providers, if they have appointments available. Seems pretty simple. And here's our architecture. The architecture, again, matches what we saw. Seems pretty simple. Front end, back end map, a cache. We have an appointment availability API. We also had a provider dashboard. Providers log in, give inventory about their, give inventory information back to the government. The complicated part here is not the architecture, but the fact that this architecture diagram is an org chart. Almost every component here was owned by a different contractor or subcontractor or sub-subcontractor or a different government agency. maybe government agencies that were technically under each other but don't really operate together. And that is actually a very complicated thing to manage. So on top of that, I'm here from USDS. USDS is not in this org chart. I'm going to go a little bit into the appointment availability API. This was supposed to tell us where the appointments were. We knew about the inventory from providers, but at this point in the vaccination program, what we really cared about was, are there appointments? Doesn't matter if there's vials on the shelves if you don't have people to put the shots in the arms, right? And so there was this weekly Zoom meeting from hell where all these different providers from around the country were present, all these different local governments were present, and we were trying to design an API by committee. So, you know, sometimes at USDS, you get to go into a meeting and say, hey, we're the White House. That did not hold any water here. The White House is not the boss of any of these providers, and the White House is not the boss of any of these local governments. We're just another busybody that has our own things that we want. And again, USDS doesn't really have authority in this situation. What we did have was SRE mindset. So how do we align all of these different groups to actually launch a government website? We were all able to align over the scenario of preparing for a primetime presidential announcement. So what happens when you want to launch a new .gov website, fancy new website? You're going to launch it when the president says your URL on TV. And let's go for a worst case scenario during the State of the Union. That was the scenario we were preparing for, and that was the scenario we all aligned around. So a high load scenario, a high scrutiny scenario, and one that could actually happen. I will say in the end, we did not get the State of the Union. We did have, President say our URL on TV in its own announcement, but that was the scenario. A lot of challenges here. One big challenge is there's no such thing as a soft launch in government. So the first thing we did, of course, was to do a soft launch. Our soft launch was at vaccinefinder.org. And this was very freeing. This is something we did our first week on the project. And then we could wait on fulfilling all the accessibility requirements we needed to fulfill, which was one area that we were lacking in. We have fewer concerns about load. We could do all the things you get out of actually launching your site and having people use it. And this wasn't like a secret website, okay? Instead of a primetime presidential announcement, we had a New York Times article to worry about. Much, much lower bar, thankfully. There were some other things we did to try to once we were able to find unity, or in the spirit of finding unity. So we created a service-optimized prioritization of outstanding work. We created a list of all the things we had to do and prioritized them. Much easier said than done. Definitely when you have all these different groups trying to work together, you can have a lot of miscommunication, stepping on toes. We saw in one case, case of circular blockers between 3 organizations. That's something we wanted to fix. Did a lot of pre-work, got together, actually were able to get us aligned on how we're moving forward, building this website. Of course, a lot of work preparing for load. An optimization we made was we moved from address search to zip code search. We could cache all the results. Not the most technically challenging thing, but something that we would not have done if we had not all been aligned and thinking clearly and working together. We did this great team-wide incident response simulation. I cannot recommend that enough. We learned so much about how these different organizations worked from that. One organization said, we don't have an on-call schedule, it's a simple thing, why would we? Another organization had a very, very complicated phone tree that all led to one person who everyone knew was going to be up. So doing the work to make that simulation happen actually taught us so much about working across these different groups. The last one, talking about the appointment availability API again, we just designed an API and then we brought it to the meetings and then we could iterate on it. I think that all of these kinds of things that we did were because, again, we weren't on the org chart, we weren't any one of these components, but we were SREs, and we could have this service view of what we were doing. We could align us all around getting this site out under these conditions, and that was able to make us successful. So took 2 months from project inception to launch. A lot of things changed during those 2 months, and this is 2 months from launching the vaccinefinder.org to Vaccines.gov. So there was a tool out there. We were iterating, we were working, but pretty good considering the circumstances. We had 110.1 million sessions in 2021, amounting to 73.6 million users. And based on some, some math, it's not a stat, it's an estimation, we had about 2 weeks shorter wait for people. Once our site was out, people were able to get their vaccines that much faster, and on a nationwide scale, that makes a huge difference. So now I'm going to hand it over to Marc again to talk about Covidtest.gov.
So I'm going to talk a little bit about, we've heard about how we can use SRE skills and approach to really accelerate delivery, focus on service. I'm going to talk about some more of the ways in which we as an organization, the digital service, we bring skills from industry into government and help the government work better around these technology problems. And so I'm going to talk a little bit about connecting technology and policy for Covidtest.gov. Now, policy in this usage is a little bit different than what it fell very strangely on my ear when I arrived in government. I kept hearing it used, and I'm like, what are they talking about? What are they talking about? Well, they use policy in government to talk about things that we might in business talk about business rules or business decisions. So policy is not about regulation making or law making, but it's just sort of the rules by which an organization that is part of the government operates. So let's once again go back to the end of 2021. These pictures, I think, will look familiar to a lot of the people here. They certainly were my experience at the time with kids who we were wondering, are they going to be able to go back to school? Should we go visit the aging parents? It was very familiar. And at the time, the White House was aware of this, and they're like, okay, what can we do? How can we help get people back into the world? And the determination was made that ordering a whole bunch of COVID tests for at-home use and distributing it to the public for free would be one of the most effective things that we can do, and that's what we undertook. So why was this hard? Well, we're all here. We all deal with scale in our own ways. This is scale in a different dimension. We had a short time to act. We had 2 months from when the idea was hatched to when we wanted to launch the website. We started with a set of 500 million tests, an order of 500 million tests that eventually, when we started distributing it, went to 1 billion tests. And we're not talking about 1 billion requests. We're talking about a billion physical things that need to be moved around the world and delivered to 150 million addresses across the United States. The package volume was really high, At the peak, the US Postal Service was delivering 6 million packages in a day. And that's a big number even for former booksellers named after rivers. That's a big number. The high-level requirements were really clear. Okay, we want to distribute these tests for free to the population of the US. We want to replicate an online shopping experience. So you come, you place an order, you get status updates, delivery information. It has to be really easy to use, and it has to scale. All of those things are straightforward, but as this room really knows, there are so many different ways to do it. And it gets hard when you have to do it fast, and the appetite for risk is so low, and you have to do it in government. So we took a page out of the typical rule book, right? The typical playbook, where if you involve the people with knowledge of technology into the decision of how this thing is built, you can often do different things than if you sort of are working from whole cloth. So the policymakers, to start with, they were thinking, okay, we want to have a website. People will come, they'll order their tests, and they'll come back and check on delivery, and we're like, no, hold on. Are you talking about user accounts? Are you talking about passwords? Are you talking about multi-factor auth? Why don't we try to keep it simple? Like, this is the standard SRE play. Let's keep it as simple as possible. So we ended up with a two-tier system. We had a landing page that was static and could be distributed and handle arbitrary load on the CDN. And so the program was announced, static landing page for more information. And then we had the order site, and I'll walk through each of these. So here's the landing page, very simple. When you first visited it, before we launched the button there, the order free at-home test wasn't there. It was just sort of like, hey, come back here to order tests. And then we had the order page, and you'll see like the simplicity really comes through here. You put your name, your address, your email address if you want updates, and then you hit submit, and that's it. We didn't say, you can't order like 1 or 5 tests. We said, everyone's going to get 4 tests. That hits the most households are covered with 4 tests. And eventually, depending on the demand, we may enable additional orders. And that's what we did over time. So as I mentioned, that landing page was just served straight out of the CDN. We used network proximate services for DNS. The static service was HTML, CSS, and JavaScript. It was very simple, could be served to as many people as wanted it, and that was very easy. We were concerned in the same way that Amy was. We were concerned about load and launch time load. Again, this would be announced in a very public manner. So how do we make sure that the system actually could scale? Well, we implemented a super simple, dumb shim in JavaScript. And it was essentially, at the start of the launch, when you came to that landing page, we rolled a dice, and 1% of people got the button that said, go and order the test. And then it was 10%, and then it was 50%, and then it was 100%. And over the course of a few hours, we were able to introduce the load to the Postal Service's order page and verify that it was scaling as expected. And I will say that the Postal Service really did deliver there. And it was a janky shim that we put in place for this phased rollout. You might get a different experience if you came using your browser on your laptop versus on your cell phone. But if we kept that short and the load, we could bleed the load on, we saw the benefit from just such a simple implementation. The architecture of the order site is also what you would expect coming from industry. So it's implemented in a public cloud. It's implemented separately from the rest of the e-commerce stack at the Postal Service. And the Postal Service runs the largest e-commerce site in the government. You can see we had an API endpoint. We used serverless processing for that. We wrote the orders into the message bus and wrote them into a file. The Postal Service decoupled the order process from the fulfillment process. So at a periodic interval, we were synchronizing from that file to the fulfillment system. Then, the planes were flying in, the trucks were coming around to fulfillment centers, and the Postal Service was packing up boxes, shipping them out for delivery. And so how did we do? Well, I think we did well. A third of US households ordered their COVID test for free in the first 24 hours, and that number went to a half in the first 72 hours. This is the graph from the CDN during that first day of launch. And there were spikes, but they were all handled really well, and the system performed very well. And this was the largest test distribution program in US history. We delivered 750 million tests. Up to this point, we've delivered 750 million tests in 185 million packages. And just show of hands, who ordered at-home COVID tests here? And was it easy to do? Yeah, that was the goal. So, the SRE approach and the conversation that we had with the policymakers to figure out how to do this efficiently and effectively were one of the key measures of the key things that led to the success of this program. And with that, I'll bring it back to Amy to bring us home.
So, SRE was a really core part of the pandemic response. All of these different stages of the pandemic all required digital components. I like to say I didn't develop a vaccine. I worked at Vaccines.gov, right? But this was not adjacent to pandemic response. This was a core part of it. And having SREs be part of these projects really made a huge difference in our ability to do these projects well or even get them done at all. I want to point out everyone in this room has the core competencies to actually make a big difference, especially in government, especially in civic tech. But I think that that can be really easy to overlook. I hope that it's been clear from our stories here that that those kinds of best practices that come from industry can really make a difference in government. So thank you very much, and I guess we'll take questions now.